All right. Good evening, everybody. Sorry. Good morning. My bad. I was still stuck in the yesterday's mood. All right. It's 10:20 a.m. in the morning, and happy Makar Sankranti. This is the first day of three. Yeah, happy Bogi for the Telugu people that are watching. We will be doing OS today, as we thought. All right. Is the live working? Hello. All right. Okay, you just need to reload and things are not working. Anyways, I hope the audio and video are clear. Okay, and we will be using Ubuntu for this one. So, we should be able to do this, right? So, this is our program. Okay, 6 header files, standard IO, standard library, UniSTD, Unix standard. Okay, Unix standard. Sysrate, systat, directory entities, file control, FCTN, FCNTL, file control. Okay. So you just open main and you create a new process using fork. And if PID is equals to 0, that means whole process is running. You get the PID. Okay, get the stats of that. Write them into a.txt. Print the file size. Okay, st underscore size. You will open directory. You will open the current directory. Structure for directory entry. You will while d dot read directory is not equals to null. Okay, you are reading one file at a time. You will close directory. You will open a file. You see, file descriptor. Terminate child process. If that's not the case, wait until the child finish. Nice. This is a standard flow. This is a standard flow. I'm just curious looking at other programs. You write minimal versions for all these programs as well. Thank you. Nice. Jira. Right. Yep, they are good. They are good. Port control using semaphore. Page threads library. Producer consumer using semaphore. Fixed partition allocation. First fit. Banker's algorithm. Uh, 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 uh. Okay, they seem too small. What the heck? Alright, they might not be that big. Okay. This is day 6. I hope there is an option for Control Z and Control V. Nice. Is it getting copied? I don't know. Yeah, it is getting copied. Thank God. Control X, Y. Alright. That checks out. have the necessary libraries. Demonstrating function calls. stdio, stdnlib, unistd, fcdnl, file control. We got 7, okay. Directory entry. One, two, three, four, five, six, 7. 7 necessary libraries. Include them and inside the main PID is equals to fork cobbit if PID is equals to 0, that means child is running. Child is running. Print. Okay. Get PID of child process. Stat as struct stat as okay. Stat a.txt fetch metadata fill with metadata. And after that as dot st size prints file size. And then what do we do? We will open directory pointer. Open directory. You will understand these blocks, don't worry. And after that, printing the directory contents. This is a direct dir is a pointer, d is the structure. So this structure contains a read directory. Okay, you are reading the directory and nice. You will close the directory. You will open a file. This seems good enough. We will open the directory and we will have a structure. Directory entry. So pointer to a structure. I guess this is pointer to directory. Pointer to structure. Contents are while d is equals to, alright, read directory of directory, while all of this is not equals to null, print the string d underscore d name. Okay, you'll print the directory name. This goes onto that, and you will close directory, open dir. Okay, nice. File, file descriptor. So we are dealing with stat, metadata. We are dealing with directories, and we are dealing with files. Int fd is equals to open. It contains two arguments: the file that you are opening and the mode. Output read only. After you open that, just close it and exit the child process. Right, else you will wait. I don't know what the null is. Get PID. Replace parent process with ls command. Execl. Bin ls null. So we have a few doubts from the above program. We have a few doubts from the programs, right? Wait, null. What does null mean? And what is the full form of Execl? And what are the parameters that it is taking? Alright. Await status. Okay. Makes the parent process pause. So pointer to an integer. I don't care about the exist status. Okay. I don't care. Alright. Execute another program. Execute a program with list arguments. You can say that. Execute program with list arguments. Exec is a family of system calls. Exec. Okay. Replace the current running program with a new program. Nice. executable file. Which program should I load? Okay. Name of the program. Okay. Let me guess, there is bin and inside it there is ls and inside ls folder there is ls executable. Bin is a folder. Binary executable. Okay. Bin ls means load executable. Bin ls. Ls means start execution. Okay. This is good. This is good by itself. So we are not copying the code, we wrote it in our own words, and now we will be trying to execute it. What do you people say? So yesterday I yesterday lib.h and syswait, right? Syswait.h sysexit fct nl what is the seventh one? Directory entry. Okay, sys status. I hope it is directory entry. Yeah, it is directory entry. We have included the necessary header files, and we will have the int main. We will have the PID. If PID is greater than 0, that means child process is running. You can just print it, why not? Child process is running. I'm loving this, man. We will get the PID. The PID of the child is D comma PID. Okay. See, this PID print 0. That's not what I want. My bad. If it is greater than 0, that means parent is running, right? We should make it equals to 0. Yeah. Now, okay. Stat. We know what stat is. Have a defined structure. It fills the stat with metadata. The size of the file is s dot st size. Okay, you missed ampersand. What is LD? Okay. So, and the file stats y ampersand s and y is the format specifier percentage LD. Core C plus OS fundamentals. Yep, we do not have this. S is a variable, it can only store metadata. Right now it is empty. Fill S with information. A function cannot modify a variable unless it knows where that function is stored in memory. Okay, it is call by reference. Call by reference behavior, okay. Long int. Call by reference metadata. Long int, yeah. Okay. Yeah, let's write it, shall we? I don't know what you think, but I'm really liking these colors, man. Okay, now we don't need to close anything, right? Directory dir open directory, or at a pointer of the directory type that opens the directory of the present. Nice. And a struct directory entry D. So now what we are doing, we are printing the contents of D is equals to read directory, contents of directory, we are reading it. And while all of this, is not equals to null, what will we do? We will print d of dname percentile yes, because it is a string, backslash n d dot d name. That's it. Yeah, that's it. And after printing we open the directory, we will close the directory. What will we close? We will close the directory. That's it. Right. File stats. Directory stats. Directory operations. How about that? We closed the directory, and now what will we do? File operations. We will file descriptor. What will we open? There is no a.txt, so we need to create that. Output is read only, and we will close fd, and we will exit the child process. Else, that means PID might be greater than 0. Parent process is running. I don't care. Just, wait until all that. The PID of parent process is percentile t get PID. After that, we will do, exec l. What will we execute? Bin ls null. Nice. That's it. Is that the flow control? Why is it in the else? Okay. You need to replace while the parent process is running. You need to replace while the parent is running. Right. So the else is closed. We will return the control with the status 0. That's it. I guess it is it. Control X, Y. enter. So now you need to touch a.txt, echo hello, this is the content in a.txt. We need to echo that to a.txt. Okay, how to read that? Cat. Nice. So fork.c. GNU or GCC? GCC if I'm not wrong. Fork.c. Oh, fork. FCNTL. Okay, controlled. FCNTL. Okay, my bad. Nano fork.c. Okay, here. CNTL. Why, yeah. How about now? Okay, my bad. Undeclared EA. A.txt should be in quotes. Yeah. A.txt should be in quotes. And read the directory. Oh yeah, that's not a pointer. Nano. Nano fork.c. I have gotten the errors, brother. This directory structure should be a pointer, and these should be enclosed in quotation marks because it is a file. Alright. Why enter? Now, how about now? GCC fork.c fork. D is a pointer. You meant to use D of dname. Yeah. Nano fork.c. Why don't you give all the errors at the same time? Alright, because there is error with directory, that's why it could not process that. Nice. Now what? Fork. This is the output. This is the output. This file. Missing something. Yeah, we are missing new line. Presentation only not loading. Okay, it is printing the directories. Hmm. We read file using int fd is equals to ni.txt comma output rd only. Why is nothing happened? Open does not read the file. A file descriptor is a ticket number. I see. Maybe let's return the file descriptor, why not? The file descriptor of presenting. That checks out. Alright. GCC fork.c, again recompile it and output and fork. And what now? Fork. Right. File descriptor is 3. Nice, right? It is pretty nice. We completed one program. Wow. And what next? The next is This is our syllabus, yeah. Let's do this. Let's do this in easy, simple. Assume zero is confidence. Write a program that behaves similar to the command, not exactly Linux implementation, obviously. List the name of files in a directory. We will open current directory, print file names. We have already done that. Okay. CP copies contents. Have two pointers, source and destination. Character buffer. Read the first file. As open. Open source file, open destination file. Character is equal to fget. File get c source is not equals to end of file. Get c and put c. Character, put the character and destination. Close them. Grep searches for a word inside a file. Have a file pointer and an array or a string of 200 characters. Open the file. Matching lines. Maybe you can. Alright. Input is not permitted in this. No, I think input is permitted if you use scanf. Okay, open is a kernel level call. I see. Does scanf work in Ubuntu? Segmentation. Okay, people, we can do this. It's 11:10. Nice. We need to do this now. Right. What are you simulating, ls? CP and grep. We will simulate all of these three. Unless you need directory entry for ls, absolutely. It is same as what we had previously. There is 1, 2, 3, 4, 5, everything same. All that matters is 1, 2, 3, 4, 5, 6, and 7, 8 lines. That is all. Alright, people, I will come back in 2 minutes. Okay. All right, people, we are back. Yeah, 5 minutes. That's it. So we will write these things. Right. What do you do first? You will have directory, and you will have directory entry, pointer entry. What I'm trying to say is it can handle the directories. So while d is equals to read directory, all right, you will open directory, all right, and you will read the contents of directory. Is not equals to null. While the contents are not null, you will print d of d name. So that is ls, and you will close directory. That is the basic simulation. And CP is copying the contents. Do you copy contents? You open a file. You have two file pointers, source and destination. You will open the fopen works. Yeah, fopen takes two parameters and the mode. Similarly, destination is in the right mode. So while get C and put C, and you will have character C as well. This acts as a buffer. While character is equal to F, get C, source file. You get the character from the source file one by one, and it is not equals to end of file. Until then, you will put C. All right. F put C in the I will put the character in the destination. We just need to know the parameters. That's it. Close source and destination. That's it. All right. You need to search. You will open the file and you will get the line. Okay, get C gets the character, get the string line. Okay. str, all right. I have understood the lessons AP, but in grep, what are the parameters for fgets and what is str? Buffer size file pointer. Okay, line is a buffer. Size of line, file pointer, alright. F gets syntax. It will have buffer and it will have size and it will have F pointer. That checks out. Okay, it checks for a string. String, substring, okay. So in the line, we are checking if there is a substring OS or not. That is what we are trying to do. Okay, have a FP file pointer and buffer. Have these and FP is equals to F open. A.txt maybe in read mode. R mode, yeah. While F gets so it will get line and size of line from the FP as long as the line exists. If string of line and OS, this is string and substring, is not equals to null, it will print all instances, right? Yep, percentage is line. It will print all instances of line and close the file. That's it. Okay, the laptop's crashing. Maybe on the battery balanced, yeah. Okay, let's write it. We have a.txt, alright. Maybe let's write, let's append something to a.txt. Echo, this is OS. This is OS lab. Let's append it to a.txt. Nice. Things are working out. And now what? Echo OS a.txt. Yep. I guess it is case sensitive. All right. And now we will open DXP 2.1.c. Nice. So let's have the standard output of input output directory entry. Now what will we do? We will have a directory pointer. We will have a directory struct directory entry. I really hope it is D. It is not directory entry. It is directory entry. Yeah. It is directory entry. All right. So we will be getting the lines of. No, first we need to open directory, right? You will open directory and store it in the pointer. Nice. You open the directory, and while D is equals to read, you read the directory. What do you read? You read the directory of D and is not equals to null. As long as it is not equals to null, okay, what will you do? You will print the directory. Printf, it is a string, alright. \n, you will d of d name. Nice. And now you will close directory. You will close the open directory. Return 0. Or maybe you can get the input from the user as well if you want, but this is easier. Okay, so we will compile it. GCC experiment 2.1.c. The output file is experiment 2.1. I did not close the printf statement. Okay, nano experiment 2.1.c. I did not close the parenthesis. All right. Nice. So now we will open the experiment 2.1 here.txt experiment 2. Yeah, it is working good. Okay, you can do experiment 1.c. Let's do the cp command, shall we? cp4.c to experiment 1.c. Nice. Experiment 1.c. Nice. And now rm4.c. Now let us compile gcc experiment 1.c. The output file is going to be what? The output file is going to be experiment 1. Now rm4 as well. Let's see the LS. Alright. You have experiment 1.c, experiment 1, experiment 2.1, experiment 2.1.c. That's good to hear. Or maybe you can execute all of these three in a single one. Yeah, you can. You can like print executing ls, executing cp, executing grep. You can do that. You can do that if you want. All right. Printf executing order executing ls. Printf executing cp. Executing ls on pwd. a.txt to that should be enough description. Let's have a source and destination file pointers. File src destination pointer src is equals to fopen a.txt in the read mode. Destination fopen b.txt in write mode. Let's have a character buffer because we are copying it character by character. You will read the contents. So for that fget c, you will use fget c while fget. Okay. It will return the source fget c from the source. Fget c returns the character is not equals to null. Is no there is not equal to end of file. Yeah. F put c, you will put the character into destination pointer. That's it. And you will close source and you will close destination. You will say the contents are Copied successfully. That's it. Okay, even if there is no b.txt, I think it will create by its own. If it does not create, we need to manually create. We'll check that. Let's compile it again. Experiment 2.1.c. The output file is going to be experiment 0.1. The read and write modes need to have quotations. Okay, that makes sense. Does it not? Nice. And now we will run that. There is b.txt, yes. Nice. Right. You need a backslash n. And now what? Executing grep. What do you mean by etc.? These three are more than enough. So for grep, here we used get character and put character. There we will use get string and put string maybe. F gets and F puts. And the syntax is a bit different, but it's alright. You need buffer, size, and file pointer. So create a buffer. Size is size of line. Yeah. String of strings maybe. What does str abbreviate to? What does str abbreviate to? Let's see. String, yeah, string and string. We understood it. We are executing grep now. File fp. What does it point to? Fopen a.txt and the read mode. Open the file and have a pointer pointing at it, and then have a buffer. And now what will we do? While f get string, it's actually buffer size and fp. As long as that exists, you can write it as well, that doesn't hurt. Everything's clear? Yeah, everything's clear. Is not equals to null. What will you do? As long as it is not equals to null, you will if str, what is the string in the line? You will check for OS is not equals to null. You will print it. You will print yeah, you always need a format specifier or line. You will print the line. And then you will close it. That's it. No, this is not it. Expected expression, alright. F gets, this opens, this closes here. Okay, right, this opens, this closes, this opens, this closes. Yeah, we put an extra bracket. See, 1, 2, 3, 1, 2, 3. ACC experiment 2.1.3 experiment 2.1. Implicit declaration. String.h. Okay, you need string.h for that. That's what it is basically saying. And I did not put a semicolon at the end. Yes, got it. I am able to read errors. So you need string.h. Okay. This is a while close. Nice. Experiment 2.1. Nice. 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 Things turned out to be good. The fourth one. Thanks to you. Yeah, thanks to you. Yep, we are coming over there only. CPU scheduling. CPU can run only one process at a time. Like a QA counter. Okay, have some burst times and have some waiting times. First process waits at 0. Okay, got it. So 0 plus 5, it will be 5. I see. Have some burst times and sort the burst times. Just nice. Priority scheduling. Alright, this should be easy, man. Have the process IDs and have the priorities. And sort the processes according to the priority IDs. Round robin, Have the best times and time quantums. Nice. And done is equals to 1. Should I get my keyboard? Alright. This should work out. We can do this like in an hour or two. No, it takes like half an hour to 1 hour. That's it. And we also thought of copying that experiment 2.1 to experiment 2, right? Why is it unstable? Okay. Okay, people, the base is fluctuating like a lot. Oh my god. GCC experiment 2 dot C output file is going to be experiment 2. Experiment 1 dot C, alright. Nice, right? Nice. Only if I look at the task manager now. Nothing crazy. Like a lot of memory is being used, that's it. Okay. CPU. Yeah. There is no force for NVIDIA whatsoever. So I just need to understand this round robin. How do you want the output? Like process 1, process 2, process 3, and when the is completed, notify. Time count. Yep, P1, P2, P3, P1, P2 stun, P3. Yep, P1 stun, P3 stun. Have the number of processors, have the best times for processors, have the time quantum, and completed process count. Wow. While completed is less than n, if burst time is greater than 0, you execute it. Time is greater than time quantum, just subtract it, else put that to 0 and process completed. Increment the completed. Nice, nice dude. And what's the next one? So I will complete this one today and then I will sleep. Four CPU schedulers. So what do you do? Have BT. Wait time of 0 is equals to 0. I don't want to write the code because that will be copy pasting. This is the first come first serve and priority. So you will just have burst time. Okay, you don't need burst time. So what do you need? You need process and you need priority. Sort by priority. Both are S. Bubble sort works out. Print process. Process X with priority Y. And sort this job first. Get the burst times. Sort them. Maybe get the P process. Print them. Sorting by burst time is shortest of first. Sorting by priority order is priority scheduling. It is same logic. It is same logic. RR scheduling. Okay, what do you do? You will have M. You will have completed. You have loop controls. Now it should be showing. I don't know. Yeah, it should be showing now. If it is not showing, just tell me. Okay. So n uncompleted are loop controls is equals to 0 is equals to 3. What do you do? Loop. All right. We are going to, loop through every process, right? So if the burst time is greater than 0, BT is greater than 0 means executing reduce bt. Bt is greater than tq. Bt minus tq. Bt minus is equals to tq, yeah. Else Bt is equals to 0. Put the burst time is equals to 0. Process completed. And completed plus plus. Nice. We should be able to write this. Nano will open experiment 3.c. Yeah. So what do we need? Since it is just arrays simulation, stdio will be enough. Let us simulate this. Simulating FCFS. So what is FCFS? You will have burst time that is predefined, and you will have wait time. Okay. Int burst time of 3. Let it be 3, 4, 5. Let's have wait time array as well. And initialize the wait time of 0 is equal to 0 because the first process does not wait. That is FCFS, right? Sorry. Do we have any comments? No. So the first process wait time is 0, and now you need to calculate the wait times, and you just need to print them. Okay, I don't know if int I works here or not. Let's see. I less than maybe you can directly hardcode 3, or maybe size you can also do something like this. Int size is equal to size of bt by size of bt of 0. You can do something like that if you want. Less than size I plus plus. So what do you do is you need to calculate wait time of 1 and 2, right? So you will start from 1. So it will loop 1 and 2. Alright. Wait time of I is equals to wait time of I minus 1 plus bt of I minus 1. Yeah, because the burst time, the wait time of 1 will be what? 3. So that will be 0 plus 3, and the wait time of 2 will be what? 2 will be 3 plus 4, that is 7. And will it get to wait time of 3? The size is 3. So it will only execute 1 and 2. Okay, we need some math here. This is 3, 4, 5. This is BT and this is WT. So how do you calculate this? 0 plus 3, you will get 4. Sorry, my bad. 0 plus 3, that is 3. And you will get 3 plus 4, that is 7. That's it. This burst time does not count, right? I mean, after executing, all processes will be executed after 12 seconds. After, because 7 plus 5 is 12, you can also write that if you want. So you calculated wait times, and now what will you do? Okay, process 1 waits for 0 seconds. You can print like that. For int I is equals to 0, I less than size, I plus. You can write something like this: printf process %d waits for %d maybe milliseconds. So what is I plus 1, right? Or you can do one size here. That's your wish. And how many wait time of I? That's it. It is void, so we don't need to return anything. That's it, I think. GCC experiment 3 dot C output final experiment 3. Nice. Experiment 3. Process 1 waits for 0 milliseconds. Process 2 waits for 3 milliseconds. Process 3 waits for 7 milliseconds. That's cool. We just missed a backslash and that's it. We just missed a backslash and that's it. All right. You can print the data maybe. How about that? You can print up the info, right? After declaring the array, you need to print the info. Print burst time of process %d is alright. Let's be compact. What is the burst time? BT of I. Nice. Simulating shortest job first. SJF. So how do you simulate that? Again, you will have some burst times. Ouch. You will have burst time, you will have process IDs. Maybe you don't need processes. Yeah, you need processes. Int p3 is equals to 1, 2, 3. Int bt3 is to 5 to 4. Okay, you need something here as well. You need a backslash and printf process 1, something like that. Burst time, alright, something like that. P of I, comma, bt of I. Put it in a loop. So the initial conditions were printed. Now we need to sort them. Sort them according to the burst time. If bt of j is greater than bt of j plus 1, get a temp, right? Temp is equals to bt of j, bt of j is equals to bt of j plus 1, bt of j plus 1 is equals to temp. Got it? You can put that in a line if you wanted to. And similarly, you can also swap these two. What? You swapped the processes and you swapped the burst times, and similarly you need to swap the processes. P of I, alright, sorry, P of j. That would have caused a lot of debugging for us. P of j is equal to P of j plus 1. P of j plus 1 is equal to temp. Nice. So the processes are swapped according to the burst times. For int I is equals to 0, I plus plus. After swapping, you can write after swapping here. After, no, after SJF. Scheduling. Printf process percentile d. Maybe how about percentile d process percentile d. Something like this. I plus 1. So 1 will be process. They were swapped in the process array. They were sorted over there. Nice. That's it. GCC experiment 3 dot c for experiment 3. Expected declaration or statement at the end of input. So we messed with the brackets. This is for close. These three are these three clauses. That's main 1, 2. Okay. So 2 brackets were open. This is yeah. This was not closed here. That's open, that's closed, that's open, that's closed. Open, closed. Now what? Previous definition of BT with int 3. Okay, you cannot have BT redefinitions of BTs. Got it. I missed somewhere. Line 22. Where dude here? See. Nice. Stack smashing detected, terminated, aborted, core dumped. What the heck is this? Let's open now. Oh yeah, oh yeah, oh yeah. You forgot to swap here. Oh yeah. I don't want to ask it. Huh? Okay. Nice. Process 1. Okay, 2, 3, and 1. That's a printing error, that's it. Nothing much. We are good. We are good. 2 hours and 10 minutes. Okay. This is important because we are integrating big projects. Even though they are not that big. We will be simulating this, and for priority scheduling we need to have process and priorities. Do we need burst times? Do we need burst times? Not required. So what we do is we copy this, and we paste it. So this is process 3, and this is priority. Let's have 6 processes, why not? Priority. So we will be sorting by priorities. There will be a problem with the declaration of temp or what? I don't know. Similarly, we will be sorting the P3s. After priority scheduling. Access elements in the initializer. That's good. Redeclaration of temp with no linkage. Got it. Nano. Experiment. I don't see. Those errors are intended. Alright, process 1. Okay. Yeah, the looping variables, there is a problem with them. They got sorted well. We need to recompile it. Nice. No, why is it not printing? Okay, I put 3 over there as well. My bad, honestly, my bad. Here as well. Yeah. And we just have round robin. So we did 2, we did 3, we did 4. Maybe in the afternoon we can do 5. We can do 6. We can do 7. We can do 8 maybe. And 9, 10, 11, 12. Okay. This is difficult to complete in a single day, but we will try. And what about round robin? We will have n uncompleted. And we will have processes along with the burst times. Got it. Simulating round robin. All right. So we will have int completed is equal to 0 and n is equal to 3. It's comma. And we will have bt. What's bt now? It's bt3. bt3 of 3 is equals to, let's do 3, 4, 2. What do you say? And int slice is equals to 2. That's burst time we had, and we had processes. P3 as well. Did we use P3? Yeah, we did use P3. P4 of 3 is equals to 1, 2, 3. We don't need to print the initial conditions. Okay. While completed is less than 3. If you put less than equals, it will end up in an infinite loop. While completed is less than 3, what will you do? For int I is equals to 0, I less than 3, I plus plus. If the burst time is greater than 0, if the burst time exists, then we will do printf executing process personality. You are executing I plus 1 process. So let's make a dry run. Right. BT of I, my bad. BT of I is greater than 0. We will be executing that process, and after executing, what you should do? BT of I minus or is equals to slice. We will reduce with the slice, and if BT of I is less than slice, BT of I is equals to 0. You put the burst time to 0, and all right. I'm trying to come up with my own logic here. That's why it is taking time. 3, 4, 2, and time slice is 2. You don't need this if I were to say. So this is greater than 0. So executing process 1. Now the burst time will be 1. Okay. And now the burst time is less than slice, so it will become 0. We don't want that. We will execute. You will execute the process and you need to go forward. Got it. Completed spelling is less than. You are executing process 1. 3 is greater than 0. So you execute process 1. And then you need to reduce the burst time, right? I'll ask this for the flow. If BT is greater than 0, execute it and then you reduce the BT and then what will you do? After reducing the BT, execute process, reduce BT. No, using while unfolding. Alright, completion is less than 3. Okay, inside that. Okay. After executing, you have nested if, dude. That's nested if. I messed that thing. After executing, what you do is if the bt of I is greater than time slice in our case, if the bt of I is greater than slice, then bt of I minus or is equals to 2, or maybe minus or is equals to slice. You can remove this then, since it is one liner. If that is not the case, then what will you do? It should be smaller. Then set it to 0. And it will be set to 0, and you will say process completed. Process personality completed. What is the personality? I plus 1. We are still in that loop. And completed plus plus. Increment the completed. This is the close of else, and this is the close of if, and this is the close of for, this is the close of while, and this is the close of main. Nice. Missing terminating what? I don't see any issues with that. Expected expression. What now? See people, this is else close and this is if close. And this is for close and this is while close. Okay, you idiot. There is something here. వస్తుంది. Missing semicolon. Extra closing braces. Let's see. I couldn't even see that, This did everything. Alright. Where I missed the semicolon, dude. Completed is equals to 0. There is the black sheep. Okay. That's why monolithic is bad. 1, 2, 3, 4. 1, 2, 3, 4. Alright, this is the close of else. This is the close of if. And this is close of while. This is close of for. While for. But you also need to write a return 0, right? I mean the main clause. There should be a main clause as well, right? So it is some problem above, not here. If and else, for and while, for open, for close, for if, okay, for okay, for if, okay, for okay, for okay. So no, there should be one at the end. This is experiment 3, output is experiment 3, okay. 62, printf. Nice. Terminated, aborted, core dumped. So after simulating round robin, you use some variable names. BT3. Here. BT3. 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 Control X. Yes. Okay. Good. That is an endless loop. We need to complete this one. Slice is equals to 2. Let's ask this man. Naming issues. Naming issues. I won't write like this ever again. These are the problems that we should not be dealing with. Okay. So, completed n is equals to 3. I don't think n is used anywhere. bt3 slice is equals to 2. Then 3. bt3. Yes, bt3. bt3. But they run, right? They ran. Uh-huh. Nice. All right. 1, 2, 3, and process 3 is completed. Process 1 is completed. All right, that's cool. That should be enough for this session, people. Yeah, we did well.